Hello friends, today's question. We are given that the figure shows a square loop L of side 5 centimeter which is connected to a network of resistances. The whole setup is moving towards the right with a constant speed of 1 centimeter per second. At some instant, a part of L is in a uniform magnetic field of 1 Tesla perpendicular to the plane of the loop. If the resistance of L is 1.7 ohm, the current in the loop at that instant will be close to. So we are given this figure, and in this figure we have a loop L which is actually moving towards the right. Okay, so it is moving in this direction with a speed of 5 centimeter per second, and there is a resistance network which is basically a Wheatstone bridge. And if we look closely, this Wheatstone bridge is actually a balanced Wheatstone bridge. So we can just remove this central resistance which is of 3 ohm and solve this resistance network. And we are also given that the loop has a resistance of 1.7 ohm. So its resistance is given as 1.7 ohm, and the magnetic field in the loop are in perpendicular to each other. So this, first of all, let's write the given information. So we start with the velocity. Velocity of the loop, and please keep in mind it is towards right, and which is our 1 centimeter. Okay. So let us 10 to the power minus 2 meter per second. We are also given the resistance of the loop, and we denote this by V. Resistance of loop, let us suppose this is our RL, and that is given as 1.7 ohm, and we will be also requiring area A. So let us write area of loop. A will be our 5 into 10 to the power minus 2 meters. So first of all, let us solve this bridge network. So we can just draw the approximate circuit. And we have a resistance which is also connected between these 2 points. This is our A, B, C and D, and this is 1, 2, 1, 2. So this is 3 ohm, and as the bridge is balanced, we can just remove this resistance and we can draw an equivalent circuit, and that equivalent circuit will be something like this. So here this is A, B, C and D, and here we have 1, 1, 2 and 2 ohm. Now these two resistances will be in series, the other two will be also in series, and respectively they will be coming in parallel. So equivalently you can draw it like this. This is our B and this is our D. So the series will be coming 2 and this will be coming 4. Now these two are parallel and we can easily solve it. So we can say the given bridge network network is balanced. Therefore, we can remove 3 ohm resistance. We can remove 3 ohm resistor. So we can write the equivalent resistance let us call that as R equivalent, will be now coming as the final circuit is our 2 parallel 4, which will be giving us 2 4 and 2 plus 4. This will be over 8 by 3 and it comes close to as 1.3 ohm. So means if we remove this entire circuit, now we can simply join one resistance here and this will be our equivalent. So this circuit with respect to resistance, loop resistance is given as we have taken it RL. So this will be our loop resistance and this will be our some equivalent resistance. So these two resistances, this will be our loop and our equivalent now will be coming in series. And we can say this resistance, now we can call that R total. So we can say now, therefore, the total resistance of the entire network let us suppose that is called as R total, denoted as RT, will be equal to load resistance plus equivalent resistance, and we simply substitute the value. You get RT loop resistance is 1.7 and equivalent resistance is 1.3. So this comes as 3 ohm. Now we are supposed to find out the value of the current. For that, we are going to first of all find out the induced EMF, or the equation of induced EMF. So we can say induced EMF will be our VBL, and from here we can say current, which we assumed is E, and induced EMF current assumed as I, not E. So induced EMF divided by the resistance total. So we can say this as VBL divided by 3 ohm. Now we simply substitute the values. We get current I will be equal to 10 to the power minus 2, 1, and we have this as 5 into 10 to the power minus 2. One second, let me check one thing more. Side is given 1 centimeter, okay? So here it has to be side, not area. Side, and this we denote as L, or rather we can say small l. Yeah, now it's correct. And divided by 3. So we can write that our current will be approximately equal to 1.67 into 10 to the power minus 4, and this will be in amperes. So if the options that are given to us, we can check, it can be approximately as 1.7 microampere. Okay, so let me convert it to microampere. So this can be approximately at 170 microampere. So option number B is the correct option. Option B is correct. So this completes the question. Thank you.